if your coin is flipped 3 times, what is the probability of resulting exactly 2 heads and 1 tail? As I said at the end of my previous video, when you flip a coin, whether it's fair or unfair, you either get a head or you get a tail. So we only have 2 possible outcomes. And if we repeat this procedure multiple times, for example, in this case, we repeated 3 times, what we have is a probability, a binomial probability distribution. When we have a binomial probability distribution, we could use graphing calculator to calculate, for example, the probability of getting exactly 2 heads. Notice the question says exactly 2 heads and 1 tail, and we don't actually, if you really think about this, we don't actually need the very last phrase, because by default, if we flip it 3 times and we want to get exactly 2 heads, of course we have to have 1 tail, unless your coin has the capability of to stand at its side, which doesn't happen. So we have a binomial distribution. To use your graphing calculator, we need to figure out a couple information. One is the total number of trials. In this case, that is 3. P is the probability of success. In this case, we define success as getting heads. And that is 1/2 because we are talking about a fair coin. And the number of success. In this case, we want to have 2 heads. So the number of success is 2. And the function we are going to use is called binorm PDF. There are 2 functions that are very, very similar to each other. In this case, because we want exactly 2 heads, and we will use PDF. So the syntax is to enter n, p, x. And in this case, I will enter 3, 0.5, and 2. So pull out the graphing calculator. I will go to second, VOS, and I will scroll it down to 8, binomial PDF, and press enter, and it's waiting for me to enter 3, 0.5. 0.5 is equivalent to 1/2 and 2. Press enter, and that is my probability. Isn't that so much easier than, oh, perfect. Isn't that so much easier than this previous calculation? So from now on, you're welcome to use your graphing calculator. Next step, I would like to find the mean and the standard deviation. So the mean and the standard deviation. Previously, we used the table and the graphing calculator. Now I'm just going to give you the formula, which is the mean equals m times p. In this case, we have 3 times 0.5 or 1/2. So the mean is 1/5. And the standard deviation is m times p times 1 minus p, which equals 3 times 1/2 times 1 minus 1/2. So I'm just going to enter that into my graphing calculator. So it's second x squared and 3 times 1/2 times parenthesis 1 minus 1/2. Close the parenthesis and close the parenthesis again for the square root. And that will give me 0.9. So with binomial distribution, this is how you calculate the probability, the mean, and the standard deviation. And once again, binomial distribution is when you have a situation that you either get, for example, the head or tail, only 2 possible outcomes. And then you repeat the experiment or the trials multiple times. In this case, 3 times.